MEE, Multi-Effect Evaporator. Multi-Effect Evaporator is the most efficient and successful conventional evaporation method to achieve the desired outlet concentration for any type of industrial effluent. Prior to beginning of the evaporation process, first cooling water circulation is started and the generation of an appropriate vacuum is being maintained by the vacuum pump. The purpose of generating the vacuum is to lower the boiling point of water. Through the feed pump, the feed from the feed tank enters the shell and tube heat exchanger called calandria by passing through the series of preheater. Preheaters are used to exchange the sensible heat of condensate water generated during the evaporation process to increase the initial temperature of the incoming feed, simultaneously decreasing the temperature of the condensate water, which leads to a decrease in the total energy requirement for the entire system. Now let us understand the concept of evaporation by taking single effect evaporator. From the preheater, the effluent goes to the recirculation line of calandria 1 and enters the calandria from the bottom of the tubes by forced circulation through the recirculation pump and travels in the upward direction. To start the evaporation process, external steam is being provided into the shell side of the calandria. Due to conductive heat transfer, steam passes its latent heat to effluent and evaporation of water from the effluent takes place. A water-vapor mixture is being generated which goes to vapor-liquid separator called VLS. In VLS, vapor is separated from water-vapor mixture by means of gravity, while the concentrated liquid is recirculated in the calandria by a recirculation pump. Pure water vapor from the top of VLS is condensed in a condenser, which consumes 1 kg of steam to evaporate 1 kg of water. Let us now understand the concept of a multi-effect evaporator. Vapor generated in the first effect will pass into the shell side of the second effect and will be used as a heating source. From the overflow line of vapor-liquid separator 1, concentrated liquid passes into the recirculation line of calandria 2 for further concentration. Due to conductive heat transfer, the vapor passes its latent heat to effluent and evaporation of water from the effluent takes place. A water-vapor mixture is being generated which goes to VLS2. Thus, by adding the second effect, water evaporation doubled for the same amount of steam used in a single effect. For further improving or increasing steam economy, we can add more number of effects. At last, from the bottom of the last effect, reject of the MEE at the desired concentration goes to 80 FD for final solid-liquid separation and thus achieving a true meaning of zero liquid discharge. This way, by adding number of effects in the system, we can increase the steam economy, which leads to a reduction in steam consumption and operating cost of the zero liquid discharge system. A decrease in steam consumption also leads to lowering the size of the boiler, which means an overall reduction in carbon footprint.